So let's get started with worksheet number 8. This is 11.7 and 11.8. So 11.7 is basically permutations, and 11.8 is combinations. All right. So our purpose today is to figure out what's going on. Look at these formulas. Why does it look so weird? And then what's the difference between the two formulas? And then we may have time to start off like when to use it, when not to use it, stuff like that. But we have plenty of time. So Thursday we're going to do a little bit more discussion on when to use it, when's the appropriate time to use it. So I want to start, guys, by saying that raise your hand if you have a 4-digit PIN number, PIN code for your ATM, like to get money out of the bank. Okay. I bet you that I could figure it out. Okay? Because it just has 4 digits, 4 numbers, and we can safely assume that you are allowed to repeat the numbers. Okay, and each space, each spot, first, second, third, fourth digit, you can choose 10, right? You can choose whatever you want. So that you can choose 10 numbers, 10 digits. So we got 0 through 9, right? Does anybody's code start with a 0? Yeah, that's not very common to start with a 0. We have 1. Okay. Over here, how many digits do we have? Yeah. So 0 through 9 in the first one, 0 through 9 in the second one, and third and fourth one, right? Because there are no restrictions on this. Okay? So the third digit that you have is any number between 0 and 9, so that's another 10. Okay, so just like in the test, this previous test, there was something called the counting principle where you just multiply 2 numbers. Okay, this happens to be the same number, and it happens to be repeated 4 times. Okay, let me put this on pause. Tell me the answer. What is, or how many possible combinations would I have to go through to try to figure out your code? Ten times 10 times 10 times 10 is 10,000. Is 4 zeros, right? Very good. 10,000 possible combinations or possible codes. All right. That's a lot of codes for me to sit here and go through. Now, somebody's at the ATM and they're trying to, you dropped your card and they took it and they're trying to go in. Obviously, there's a camera there, unless they blocked it. And then they would have to sit there and try 10,000 different combinations. That's not really going to happen unless they have technology. Now, they have to have a legal piece of technology that goes through the 10,000 codes really fast. Okay? Then you should be fine with the 4-digit code. But this is why passwords should be long, okay? Because how many letters are there? 26. So right there in that first spot, there's 26 options. And then, it makes it worse when you have, for the thief, you have numbers, letters, and they add, put a symbol. Now there's more symbols. So you're making this thing longer, making it more options. So this number is going to be like, trillions, okay? You have to be a very smart thief to be able to, hacker or whatever, to be able to crack those codes. All right, so this is why, because it's multiplying all the different options that we have. Now, guys, what if I say, okay, now you have to change your number and you cannot repeat any numbers? Anybody have repeating numbers in your code? I do. Okay, so that means that's a restriction. All right, and actually we're making the number smaller. Let's see how much smaller. So let's redo this, but this time no repetitions allowed. Okay, which is similar to what we did with the marbles and stuff of without replacement. Okay, very similar to the whole without replacement. Okay, so if I pick a number for my first spot, I cannot pick that again. That's like saying if I have numbers in a bag, once I take it out, I can't choose it again. There's less to choose from. How many less? Just one, right? So if we do this code again, the first option we have the 10 digits, 0 through 9. What about the second option? How many? If we pick one, okay, we don't have as many. So we have 10 here, but now we have one less. So we have minus 1 here. So we have 9 numbers to choose from here. And then we have 8 and then 7. So notice how the numbers go down by 1. Okay? Which reminds me of a question that many of you missed on the test. So let's talk about that for a second. Let me put this on pause. Okay, guys, so how many options from our second code here that you're not allowed to replace? You're not allowed to use the same number twice. So how many is that? Calculator time, guys. You should have your calculators out. $5,040. So we just so just by putting that one restriction, we cut our options in half. Okay? You never want to put a restriction if you want to have lots of options so that your code is secure, so nobody's stealing your stuff. Okay? So just by putting that one little restriction, taking away one number each time, we have half as many options. So that's not good for the consumer, but that's great for the thief, okay, or for the hacker. All right. So guys, notice that the number 10 was subtracted by 1 every time. You know there's a symbol for the 10,000, right? How do we get the 10,000 with 4 tens? What's the math symbol for that? Ten multiply 4 times 10 times 10 times, that's 10 to the 4th power. So there's something called the exponent. Well, there's another symbol for 10 times 9 times 8 times 7. Does anybody know what that is? It's called factorial, okay? So it's an exclamation mark. Okay, even though that's English grammar or whatever, we use it in math to show something called factorial. So let's say we have n, so some number factorial, that basically looks like this, n exclamation mark. Now, you guys should have this symbol in a scientific calculator. Every calculator is different, so I don't know how to help you really. Okay? Some have the button visible, some have it in the back of the button, or so you have to press second. Some have it in a menu, like mine. So if you have a TI-30X like mine, I have to click on probability, PRB, okay, because we're in the probability section. And I have 3 options to choose from. I have an arrow button I can, So I actually have a P, a C, the permutation combination, and the exclamation mark. Okay? So once I put that in there, this is what it's going to do. It's going to subtract 1 until you run out, until you run out of numbers. So 10 factorial is going to equal 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So you can do this manually in your calculator, or you can use the symbol to save you all the trouble. Okay? And how much is this? So remember, we went from 10,000 to 5,000, because we only used 4 numbers for the 10. What if we use all the numbers in front of that 10 until you get to 1? How much is this? $3,628,800. Okay. Notice how things have gotten pretty large here. So what this is taking us, guys, this right here is introducing us to the concept of a permutation. Okay, permutation. In a permutation, okay, not an exponent. A permutation. It's without replacement. This is why the numbers are decreasing. It's without replacement. Okay, so the numbers are decreasing. All right. But how do we get? Is there a formula for only using the first 4? Okay, because if we just put 10 exclamation, we're going to use all the numbers. We're going to get 3 million. How do we get 5,040 from this? How do we take out the numbers we don't need? Okay, that's the question that we're going to answer with this formula I'm about to show you. So, going back to the number 10. So for the 10 factorial that we just calculated, which is 3 million something, how can we cancel out the part that we don't need? So remember, this one over here is missing 65432. How do we get that out? Okay, how do we cancel that 65431? So that we only calculate just the first 4 numbers, okay? Because guys, your calculator is not going to do this for you. If you put 10 factorial, it's going to multiply all the numbers of 10. But how do we only use the first 4? Well, you're going to have to do this little manually, okay? So there's a formula that will do it for you, but you have to find it, okay? It's called permutation, and it looks like this. There's a big P, there's a subscript N on the left, and a subscript R on the right. Okay? So on my calculator, because it has 2 lines, and it has an arrow to like move around, I can see it. So your calculator may have a button like that looks like this, or it comes from a menu. I can't really. There could be 10 different calculators here. All right, so you're just gonna have to go online, go to Google, search for your model number. It's gonna bring up the manual. It'll put manual or something, and then it'll give you a PDF. You click on it, you read, go to the probability section and see how to type this in. All right, this is only saves you time. It is really not that necessary. Okay, So here is the formula that it's calculating in the calculator. It's going to do 10 it's going to do the number you put factorial, but it's going to divide out or cancel out the stuff that it doesn't want. Okay, so for our example, for our code, we don't want 6, 5, 4, 3, 2, 1. We want that out. So this is how it comes out. If you subtract those two numbers, the n and the r, and do the factorial of the difference there. Okay? So let's see how this works. So, every calculator is different. Okay, every calculator is different, so you have to just look up how to put this in your calculator. I don't think it's that crucial, okay, guys? So, for example, let's take a look at the first one right here. The formula says to put the 5 on top. That's 5 factorial. So we have 5 items. But the little 2 on the right is saying this is how many we're going to use. We don't want the whole 5. Okay? Because if we did the whole 5, well, that's just 5 factorial. Go find the exclamation mark in your calculator. But because we want to take out the other part, we use this formula in our calculator or by hand. So we got 5 minus 2, which is 3. Okay. What effect does that have? It's going to cancel out everything from 3 onward. So what is that going to leave you? Just the 2. So what is the real calculation here? 5 times 4. Which you don't need a calculator for. Okay, none of this right here you need a calculator for. As long as you know what to do with it. Okay? So go ahead and try number 3. See how you do with that one. So it's 6p2, or the way we read that is a permutation of 6 items selected 2 at a time. It looks scary, but it's not. Okay? All it's doing is saying, I have to divide out the stuff I don't want to use. And guys, here's the shortcut for this. Okay, let's do number 5. The shortcut. Here's the shortcut that I'm talking about. The 3, here's 14. 14 factorial. Okay? The 3 is telling us how many of the factorial numbers we're going to be using. Okay? So you know it's 14, 13, 12, well, the 3 is saying, hey, just use the first 3 numbers. Instead of using this big formula, all you have to do is say, I'm going to write down, I'm going to start with 14, and I'm going to go subtract 1, and write 3 numbers. So what would this be? $14, then 13, and 12. That's it. That's all the formula is trying to do, but you can actually do this yourself on your calculator. So if you have a basic calculator, you can just do 14 times 12 times 13 times 12, okay? And you're done. Which is what? Yes, very good. Okay. Okay, look at number 7 and 8. Are we this without the big formula or without the P and the C? This is just saying use all of them. That's what the exclamation mark with no P, no C is saying. Use all the numbers. You're not allowed to cut anything out. So that one, you have to take your calculator and do 6 times 5 times 4 times 3 times 2. Or, if you have a little symbol handy, then just do 6 symbol, enter, boom, go. And that's the difference. Those who use all the numbers, both of those are using some of the numbers. Okay? So we haven't talked about the C yet. So let's talk about the C. All right, I don't really have room to do it here. I'm going to do it in the bottom. But let's talk about the formula first. Okay, so why do we even have another formula? So here's the problem with permutation. Permutation, okay, remember, it's without replacement. In other words, you can't repeat the numbers, so it goes down by 1. And order matters. So here's the thing. Order matters. Okay? Order matters. So what if order didn't matter? Then we have a different formula. Okay? We have a different formula for order not mattering. Okay? So again, order does not matter. Okay? So what difference does that make in math? Okay? Okay? Let's talk about this for a second. Let me put this on pause. So let's take a look at this extra part of the formula. So we're actually it's gonna look just like the other formula. It's gonna look like this formula. So it's gonna have the n factorial. It's still going to have the difference, but it's going to have this extra piece. And the extra piece, the reason why you're going to see something extra is going to, this is double count. This is counting more than once right here. So you're going to divide out another r factorial. Okay? So the r is going to be in there twice. So this right here, what's the purpose of this guy here? It cancels out duplicates. What do I mean by duplicates? The same stuff in a different order as a duplicate. Okay? So we gotta make it less now. Alright? So let's take a look at number 2. Actually, no, let's take a look at number 4. Number 2 is a little weird. I'll get it in a minute. Okay, so number 4 says a combination of 7 items, okay, but arranged 2 at a time, where order doesn't matter. Okay, great. I have to subtract these 2. And I have to put another piece of it right there. Another 2. Okay. So what does this look like? It just has an extra piece. So 7 minus 2 is 5. Okay. So you could actually put that in your calculator if you wanted to, but kind of it's a little bit of a hassle if you have to go through all kinds of buttons to get that exclamation mark. So why don't we just break it down? Okay, 7 times 6 times 4 times 3 times 2 times 1, 5 times 4 times 3 times 2 times 1. That's the left side. The right side is just 2 times 1. Okay. So if we have all these numbers in a fraction, the bigger one is good because I can knock out most of the top with the bigger factorial on the bottom. So the 5 factorial actually takes care of these 5 right there. Gone. Goodbye. Now I have 7 and 6, but I also have this extra 2. Okay? I have an extra 2. So if that 2 wasn't there, we would have 7 times 6 is what, guys? 42. If this was a permutation, it would be 42 different options because if you flip the order, that counts as an option. But imagine now you say, okay, flipping the order doesn't matter, so now that's going to get cut in half. So that's what the 2 is going to do. It's going to say, well, actually, order doesn't matter. So now we only have 21 options. Okay? Who cares if it's in a different order? This is why you have less. Okay? So this is what the combination formula does. All right. So guys, I'm not here just to teach you mechanics like you're a robot. Okay, I want to explain why you see different things and why there's differences between formulas. All right. What is the formula trying to accomplish? All right. So that 2 is taking out duplicates. All right. Now, why don't you try? Let's try number 2. But I need to give you a quick word. Anybody know what 0 factorial is? It's 1. It's not 0. Okay? This is something you have to remember. Put it in your calculator and you can see for yourself. 0 factorial is just 1. This is something that that is, okay? So keep that in mind when you do number 2. Now you could probably save yourself some time if you kind of think about what's happening here. There's 6 items, and we're going to choose all 6. We're not choosing some of it, we're choosing all 6. And order doesn't matter. (20, 19, 18). So that saves us from writing the whole thing. The only thing you have to do though is make the 17 disappear. That's why it disappears. That's why you used only the first 3, because the 17 is canceling it out. So what's left over? 3 factorial. Which is just 3 times 2, which is 6. Whoops. And then you could type all this in your calculator if you want, but we can actually make our numbers a little bit smaller. Say, hey, 3 goes into 18 6 times. 2 goes into 20 10 times. So really I just have 10 times 6 times 19. 10 times 6 is 60. That's all I have to put in my calculator. 60 times 19. Or you can just put everything in there. It doesn't matter. It's up to you. I'm just trying to simplify this a little bit. So 60 times 19. It's this right here. Yeah. Okay, on the back, guys, I just want to do 1. Okay. So go ahead and take out a sheet of paper. You're going to turn this one in, and We're going to do a few, maybe one more problem from your test. This is really where we can start applying the two different formulas, where the order matters, the other one does not matter. So the question, if you're going to answer which one to use, this is all mixed up, you have to ask yourself, oops. Does the order matter? Okay, because if order matters, you're going to use permutation. If the order does not matter, you're going to use combination. Okay? That's how you know the difference. Now, this one's a little bit vague, but let's talk about it. A photographer wants to arrange 3 children in a row for a family photograph. In how many ways can this be done? If he rearranges the children, will they be a different picture? Yeah, it's a different picture. It's the same people, but it's a different picture because, let's say you started with oldest to youngest. That's one picture. And then you did youngest to oldest. That's a different picture. Same people, so the people part doesn't matter, but it's a different order of how the kids were arranged. So here, yes, order matters. So we're arranging 3 children and we're putting them 3 at a time. So this is basically the same thing as just, 3 factorial, okay? That's the same thing. We're choosing all of them. We're going to use every single number from that factorial. We're not going to, cancel out, take out a piece of that. All right, so that's all you have to do there. And let's do one more, number 12. We'll do the rest on Thursday. Does order matter? A consumer group plans to select 2 televisions from a shipment of 8 to check picture quality. How many ways can they do this? Does it really matter how they do this? Does the order matter? Okay, what do you think? No, just pick 2 and that's it. Okay? So the order does not matter. So you're going to use the C. Okay? So you have 8 televisions and you're selecting 2 at a time. So while you're doing that, I'm going to be passing out your tests.